All right, good morning, guys. So we are going to kind of continue with where we left off with the last lesson. I'm going to cut out number one. And we're going to be writing linear equations, except whereas with the previous lesson we had the slope and a point, now we're going to be given 2 points, and we're going to see what we would have to do in those scenarios. So let's recap what we did with the last lesson. So it says write the equation of a line with a slope of 3/4 passing through 12, 17. So I'll write my equation of a line. I'll fill in all my information, right? So my slope is 3/4, my x-coordinate is 12, my y-coordinate is 17, I'm looking for b. So 3/4 of 12 is 9. So it gives me b is equal to 8. So when I put it all together, I get y equals 3/4 x plus 8. So let's take a look at a scenario like this. What would be the equation for the line that passes through these 2 points? So what do I have? Well, instead of having 1 point like I had yesterday, I have 2 points. What don't I have? I don't have the slope. Well, I need m, right? And I need b. So I don't have either of those things. Which of those 2 things can I find using these 2 points? Well, I can find the slope, right, if I want to use the slope formula. Right, we spent 3 days talking about slope and slope formula for good reason. All right, so let's say I have it labeled like this. So my slope is going to be my y2 minus y1 divided by x2 minus x1, which is going to be 6/2, which is 3. All right, great. So I've got m is 3. Where do we go? Equation of a line. Y equals mx plus b. What do I know? I know that m is 3. Okay, what else do I know? Well, with the last lesson, we had a point, so we would substitute the x and the y coordinates from that point. Now I've got 2 points. So my question doing this in class is always, well, which point do I use? And we have a little discussion. And then someone that's really with us is going to say, well, both of the points are on the same line, so technically you can use either point, and that's exactly correct. You're going to use whichever point is easier for you. So in this one, it doesn't particularly matter. I'm going to use the second point. So I'm going to use x is 4 when y is 7. So I get 7 is equal to 12 plus b. So I get b is negative 5. And y equals 3x minus 5. All right, guys, here's your rules. All right, we're going to put all this in our notes. Step 1, find the slope. Step 2. After step 2, it's kind of the same as what we did with the previous lesson, except for step 3. All right, step 2, sub in the slope. All right, what does step 3 say? Pick either point. Okay, so you have a choice, whichever one you find to be easier, and substitute that for x and y. And of course, after we solve for b, we're going to wrap it up by writing our final equation. So let's see if we can apply that here. So the first thing I do is I find the slope. So y2 minus y1 divided by x2 minus x1, which is 8/2, which is 4. So equation of a line. My slope is 4. I'm going to choose the first points. So I'm going to say that x is 2 when y is 7. So 7 is equal to 8 plus b, which tells me b should be negative 1. So my equation of this line should be y equals 4x minus 1. How would we check this? Someone's going to raise their hand and say, well, check 2, 7. And I'm going to say, okay, great. So I came up with y equals x plus 5, and when I check 2, 7, that works. And they're going to say, Then we realize you'd have to check both of them. Okay, so while I'm not requiring you to check, it's a good idea to know how to check. And how would we check? We'd have to check both, and we'd have to make sure that this equation we came up with is going to be consistent with both points. All right, let's do the same thing here. All right, let's take my slope. It's going to be y2 minus y1 divided by x2 minus x1. Let's be really careful with that negative. I know half of us, if left to our own devices, are going to put negative 1 minus 3. Now we're going to end up with a bad slope that's going to give us a bad equation. So 6 minus 0 is 6. Negative 1 minus negative 3 is negative 1 plus 3, which is 2. So my slope's going to be 3. Where do we go next? Equation of a line. What do we know? We know the slope is 3. I'm going to take the first coordinate, right? Now, if I had one ordered pair with positive numbers and one with negative numbers, I'm going to take the positive numbers. So both of these have a negative coordinate, but the first one's got 0. So it's a little less likely I make a mistake with a 0, I suppose. So I'm going to sub x for negative 3 and y for 0. That's going to give me 0 is equal to negative 9 plus b. So when I add 9 on both sides, I get b is equal to 9. When I put this all together, I get y is equal to 3x plus 9. 3 points lie on the same line. What is one possible value for x comma y? Well, I could do this in one of 2 ways. I guess technically 3 ways, the third being graphing. One thing I could do is I could find the equation of this line. So if I was to go through all the steps that I just did, I'm going to get y equals 2x minus 3. Right? That's the equation of the line that contains these 2 points. How can I find another point? Well, you can pick up any value that you want for x and sub it in and find your value for y. So I'm going to say, what happens if x is equal to 20? Well, 2 times 20 is 40 minus 3 is 37. What happens if x is 0? Well, that's easy. 0 minus 3 is negative 3. What happens if x is 100? Well, 200 minus 3 is 197. So that's one way we can do it. Another way we can do it is we can make a table. And we can say, okay, 5, 7, and 10, 17 are on this line. Well, what was the pattern here? Well, to get from 5 to 10, I added 5. And to get from 7 to 17, I added 10. Why don't I just do that again? Let me add another 5. And let me add another 10. And then I can add another 5, and I can add another 10. And I can do that all day. Okay? And if you see, I have a point in common here. So what's the answer? What is one possible value? Well, there's infinite, right? If you think about it, I can come up with any x value. I can substitute it and get a corresponding y value. All right? So I teach both methods, right? If you put them into a table, all you need to do is observe the change in x, observe the change in y, and do the same thing again to both of them. Or you can go through the steps, and I didn't show the steps because we just did 3 of them, of finding the equation of the line in slope-intercept form. And then you can just pick any points you want for x. I mean, the easiest one to do is just take 0 for x and then just grab the y-intercept like I did with 0 and negative 3. But you can take any value of x and sub it in and find a value for y. This is a popular question on a state test in the Regents because it makes you think a little bit, right? All the ones we just did were the same. I could give you 10 more of those, and if you could do one of them, you could probably do a bunch of them. All of a sudden, and this was actually not even on the Regents, this was on the state test a few years ago, they threw this question at people, and some of my best students, they were kind of dumbfounded. They didn't know what to do, even though it was actually kind of easier than some of the other ones. So there's our homework. So number 4 is similar to the one that we just did. So either find the equation like you do for 1, 2, and 3, and then sub in any value for x and then find the value for y, or you can think about using the table strategy that I showed on the left. As always, guys, questions, comments, concerns, you upload on Google Classroom and you post a comment.